try to differ starting masses and different starting masses determine the current from the inrush current in the started motor. Determining the mechanical currents the inductor motor. Top speed. Determining the frequency curve. 这么多 curve 是determining 我操有病吧？ 一脚是不太好，一脚是不太好。你看了吗？我看是看了，是撸了，后来才能看。Depends on the switch on this thing. Switch on the top of the side. One has to measure the inrush current in the last 3 times and determine the average inrush current. Note that the 43 measures its value of a total sine wave and that this actually has to be calculated to compare to the normal. This is down with an eddy current break. Complete the second diagram which is necessary to measure the since the motor is cool. With a ventilator on the shifter of mode. It is allowed overload. The stator of the load up to 1.2. Aim for a higher short time. The load one. One has to measure the necessary qualities in check and the different limits are. This is either dependent on Yes. So can we begin?
Yeah.
So can we start? So our next level is about induction motor. I think at least this level is simpler than what we had last week about DC motor. This was simpler one. So we don't have 5 tests to do, but according to the report, that it seems that none of them finish all the tests. I think they only have time to do the first no load test and the second load test during the lab session, but we are going to talk about everything. So the first test is about
No,
it's start test. Yes,
yeah,
the start test. So for that lab, our equipment are something like this. So this part is the so all the part here is on the wall. So for this is AC power supply that we have used many times. What is new is this is a fuse box. It's a fuse box. So the current flows through the power supply to the fuse box where there's also a switch key. This is the switch. So after the switch, it flew to here. Here is the Y delta switch. During next week, I think we can use it, but it's mentioned that during the final exam, we cannot use the Y delta switch. But anyhow, we can use it next week.
Oh, why can't we use it in the exam?
I don't know, but according to the record from last year's student week, during the exam, it cannot be used. We need to reconnect everything. But for next week, it's okay.
Well, I guess it's like technically the equipment does not allow us to use the Y delta box.
Sorry?
Technically, the equipment does not including the Y delta connect switch.
I think it's on the wall.
On the wall?
Yes.
Ah, good enough.
What about the device on the left side?
Do you mean what? Do you mean this?
Yeah.
This is the fluke.
Fluke.
Yes. Look. This is the multi-function meter.
It's just like the one we used, the yellow one, like we used in the first lab.
This is the one where we clamp.
With 2 pens.
Yeah,
yes.
and clamping
Yeah.
in between.
Yeah.
Okay.
Yeah. And this is the induction motor. Regulated motor. As you can see, we have 6 terminals for the data and 3 terminals for rotator. Then the rotator is connected here. Here is a changeable resistance. It is just resistant. So we can use the switch here to change how big is the resistance. Something special here, as mentioned, is a fluke buzz, and this is the clamp. But during this lab, clamp. Yeah. During this lab, something special that because in the start test, the current may not to be so big, so there's some trouble that we need to want the wire more than 1 times on the clamp. Sorry. So for example, this clamp in the first lab of transmission about transmitter, we just this wire this clamp we just do something like this.
Yeah.
But at the time we may need to wind it here.
Why?
Because the clamp measure the current by using
The same function as a transformer. Yeah, it's not magnetic field.
Yeah.
So if this is the wire, how are we going to connect the clamp?
Thank you. That's good. So that's something like that.
More we need to make turns.
Yes, we will make a test so that the value can be bigger and the results are more accurate.
Okay.
But for this depends, we can try to only use 1 test, then we try to use 3 tests. We will see that. So do you have a question about this circuit diagram.
And
For the start test, we do not need any load. So we just do 4 different tests, like what shows in this table. So we use 2 delta and 2 y with different resistance. And what we need to measure is
so delta configuration is on the stator side, right?
yes, on the status.
On the stator side. Okay.
So what I will ask to measure as the what it was. I forgot it. It's the sorry, I forgot the word. It's the inrush current. Inrush current. We ask to follow this current. I think it is a function of the fluke, so we could just measure it. But we need to do the setting of the fluke. But since we do not have menu now, but we will know how to do it during the lab setting.
What do we want to measure? The
Inrush.
what exactly is that?
漏油. 漏油.
Yeah, I couldn't really tell. It's like when we start the motor, like the current would be like big and small.
It will be in peak.
Yeah, so we measure the peak.
Yes.
Okay.
So it's something like this. So what we
you wanna know the highest one?
Yes, the first peak of current.
Good.
But it also mentioned in the document that this it's normal that there will be a lot of difference between each measurement. So we measure it 3 times, then take the average.
And then divided by square root of 2.
Because it's RMS value, so yes, we need to divide it by square root 2. So, any question about this test? Okay, then we go to the load test. The circuit diagram is exactly the same as the first one. The only thing different is we need to add some load. The load is given by this one, eddy current brake. So how to connect the eddy current brake is something like this. And for this, it's adjustable. I'm not sure, but I think it's just the big box on the floor that we use to change the DC voltage.
But how are we going to connect this one to the main circuit?
Wait, how can I show this? So for example, this is the motor.
Yeah.
And there is special equipment here. It's the eddy current brake. So it's connected to the motor mechanically. So we just use it. So do you still remember that the lab session of the bench of the induction motor there is quite big. So
the one which the last team was using on the opposite side.
Yes, there's some glass circle, I would say. That is the brake.
Okay.
So we just connect. So we just connect it like this. So this was the brake. I would say the shaft is here. The shaft is here, and this is the motor.
Yeah. Right.
So we just connect it. One to the tachometer and another to the load. And to the power supply. And for the induction motor, it's the same, but we need to add a current transformer here to measure the current.
Okay.
Then the other things are the same. For this, we only need to do 4 groups of tests, but using delta, y with different resistance. Then we record all the values.
Like those PS2 can be all measured by field, right? You could always use Fluke to measure those at PQ and cosine.
It's mentioned in the documents that we use one watt-meter method by using Fluke. So we can measure it, but we need to do some calculation.
Shit. But Fluke has the function. Just get all the data as we need.
Yes. For this, they even gave this. This is the manual about how to use the digital watt-meter by using. So it's simple.
Yes, they said it's mandatory to use the one watt-meter method.
Yes, it's in document. So we do some calculation like this. I would say. This is correct. I remember.
Wait, I couldn't find it. Did I use the wrong document?
Oh, wait.
Oh, did you use the wrong document? Which page is that?
Oh, wait, maybe I remember wrong. Because yesterday I went to read the synetical motor lab that realized that it's the induction motor, not that one.
So it's like the three-phase induction motor, so it's like three-phase synchronous motor.
Oh, yes.
I didn't see that it says it has to be used in one watt-meter method.
Yeah, but we still only have one watt-meter. But I think Fluke can do the calculation automatically.
Yeah, it could, yes.
Yeah, it could.
So it has the function to just directly get PQS and cosine phi.
Yeah, so we forgot this.
I really didn't find any mention that we have to use the one watt-meter method things.
Yeah. I think there's two, but no, but yes, we do need this.
It's not that right.
Oh, no, it's here. I found what is mentioned. It's right here.
Digital watt-meter is used to determine the power absorbed by motor. Yeah, it doesn't say that we have to use something else, so it's a digital watt-meter, so we don't need to do anything with those analog ones.
Yeah. So maybe we still needed this document, but it will be fine.
We don't need that one. We don't need it anymore, or do we?
But even if we do not have natural line, so I think we still need to do calculation like this.
We don't have a neutral line, but it's okay.
Yes, it will do the calculation automatically.
Yeah, it will do it itself.
Yeah, but it's mentioned that we should read this part.
Really? Read this part, but not use this part.
Yes. So ask us to read this part.
Let's pretend that every one of us can read it.
And also for the load test, the token is how to measure the token is mentioned in this appendix. So, in short, it's just a scale that's used to measure the weight of luggage. We connect it out to the rotor. There's something special on the rotor that we measure how many weights it provided, that we divided by the coefficient of gravity that we get the force. It is a scale which will give us the value about for example 10 kilogram, which means it's 98.1 Newton. Then I remember the R equal to 25 centimeter. It is meter, so the T equal to.
What is R?
The radius.
Of what?
The point that the scale was connected. It's mentioned in document.
So it's gonna be an analog scale.
No, it's digital one. It's a weight scale. Weight.
A weight scale.
Yes, to determine the token.
Are they crazy?
Let me find it. I don't remember it. Oh, wait. I'm sorry about it. The skill is not for this lab. It's for the kinetic motors. It's not for this lab. Forgot that. Sorry. So in this we just we use this many. It's not that many. I'm sorry about it.
So still this way, how we define the torque? By what we did last time, using the relationship between the generator and
Wait, no, it is this. It is this. Yes, you can see here. Yeah, that what I said is correct. I think. I still use that skill.
what is that document?
On the Toledo.
I mean, what the name is it?
Appendix 9 token measurement with eddy current break. So the skill is connected to the eddy current break. There's some I would say ring or something that we can connect the skill or it. That we can measure the token. Oh, and also take care of the limitation. Do you follow it?
Yeah, find the document.
So any question about this part?
Can I please see the calculations?
Calculation. Oh, I have already sent this document in the group chat.
Ah, okay.
This is you can check it. So is there any question?
I had a question that is related to the lecture material. Do you know what NS represents? Like N is like the nominal RPM value. What about the NS? Like it's a slip rotational speed.
No, I would say S is the stator current.
And this is the stator current.
Stator current. This is the no. This is the rotation speed of stator.
The rotation speed of the stator.
Yes,
but stator is not fixed.
The rotation speed of the magnetic field.
Magnetic field. Okay.
And the N is the mechanical rotation speed, which means it is the mechanical speed of rotor.
So N is the mechanical speed of the rotor, and
yes,
NS is the
rotation speed of the magnetic field
of the stator.
So NS is basically like 50 hertz times 60 seconds over the P, so it's over the number of the poles over 2. So it's
yes.
like 60 times 50 over 2.
But it's measured here.
Yes, that is.
Yeah. And the N is what we need to measure.
It has 2 pole sets. Yes.
I guess so.
Yeah, I think so. Because it has over 2.
Yes.
It's like 60 times 50 over 2.
Yeah.
And the N can go from the tachometer.
Yes.
So any question about this part? Then we go to the no load test. This is where's my note?
Wait, are we ready on 5? Close enough.
No, we are on the third one.
Third one is not another one.
I saw. What is the third one?
Determine the efficiency curve and power factor curving function of the delivered power by the motor.
It's just some calculation about the based on the data we got on the load test. So usually it's also some calculation. So we go to the no load test. No load test. Where's no? Yeah. It's my calculation. Yeah. So no load test basically the circuit diagram is quite similar about what we have in the first two tests. The only difference is let's talk about this first. So we need to do two tests. The first one is about error loss and the other is about the friction loss. So we need to run two tests. The first one is to measure this, and the second one is to measure.
So basically, what we need is like to measure the total power output. Wait a moment. Because it's known up. So what we need to do is like the power output of the source itself, and the power has been consumed by the stator of the motor.
The power consumed by the stator.
And the power consumed by the whole system.
Yes.
Okay, so we just need to use the fluke.
Yes, we still fluke.
Yeah, so this part's gonna be fast. Just do it with the source. With the source that's derived out of the source.
Yes.
And do it with the whatever it is, like the stator.
Not quite correct because we need to change the current. So as you can see here, maybe I use another color. As you can see here, there are three terminals for the rotator. For the first one, we need to measure the error loss. So in the error loss, we disconnect all the three terminals. So we disconnect this.
Or you can just set the load into 0, right? So it's the same.
No, if you set load to 0, yes, you're correct. Yes. My bad. Yes. So for error loss, we disconnect all the three terminals, and for the friction loss, we short circuit. We short circuit is three terminals. So that we do the power measurement twice. So that's all. Is this part okay? You have
I think it's okay. I think in this case, do we need to do the short circuit test? No, we don't need to do that, right?
No, it's not for short circuit. It's not short circuit test. It's the.
So it's like
It's
basically
the
like
friction mechanical loss.
Sorry.
Mechanical loss.
It's like iron loss or friction loss or copper loss. Which one?
Friction loss.
Yes. So what we basically need to do is like use the whole power consumed minus the iron loss. There's no need to directly measure it, right? Because you cannot directly measure it.
Yes.
Yeah.
Yes, we use the total power to minus the stator loss.
Yeah, so basically we don't need to short circuit the whole program.
No, we still need short circuit.
Why? I see no use of short circuit it seems.
Do you have a calculator?
No, I didn't have it.
Maybe.
That's okay. Oh, I think I understand. So there are two ways to get the friction loss.
Yeah.
The one thing is it's equal to P total minus P error loss.
Yeah.
So that's one way. Another way is just short circuit that it directly the mechanical loss.
Yeah.
Yeah. So there are two ways. And the
other way is like we have to short circuit something and change the circuit.
That's what?
So the other way is like to what?
Another way is to short circuit it.
I strongly suggest that we don't do that because that means we need to change the circuit and we have to ask for an extra check. And it will waste time.
Yes, and it's from the report that it seems like that the results come from two methods are exactly the same.
Yeah.
So we can choose either of them.
Yeah, I strongly recommend that we don't do the short circuit.
Yeah.
And now we need what?
But where will the power be displayed? It's gonna be displayed on the flute.
Yeah.
Yes.
We just use the
flute.
It has the
we
function.
also use the flute. So is this part okay?
Okay. So the next part is what? Locked rotor.
Yes.
Rotor test.
Yes, but in this part we always need to short circuit it.
It's just about the rotor. So we just could we just give? No, we could not. This is not a DC motor, right?
It's not a DC motor.
So we just don't give any power to the stator. Just give power to the rotor and determine the.
No, it's an induction motor. You never give power to the rotor. The power of the rotor is given by the induction.
Ah, okay.
So you do not need the power supply for the rotor. The power supply is only for the stator.
Okay. So we need to lock it, make it not turning. It's basically about the dual loss of the rotor.
No.
So it should not have output.
No. The lock rotor test is you look at it mechanically.
Mechanically?
Yes, mechanically.
So still no need. Yes, we need to short circuit it.
Yes, we always need to short circuit. So this is the shaft. So for the rotor test, we short circuit this 3 terminals above the rotor. Then we look the shaft. Then we measure the.
Yeah, no. Should we
measure the power?
Of what? Rotor.
There's no power to rotor. It's always to stator.
Okay. So we measure the power of the stator.
Yes.
Good enough.
Yes. So that's all. And we also have DC test. Do we need to do that?
There's a DC test.
No, that's good.
That's all?
Yes, that's all.
Uh-huh.
And in case there is a DC test, the DC test is just.
Sorry.
Wait, do they have a DC?
Is there anything about DC test? Because I don't remember I was thinking that. Maybe you just make some mistake between the two files.
Yes, I think this report is 2 years ago. So maybe they changed the.
Well, judge from the
the
manuals that they touched on the machine, I think they didn't change that even like 20 years.
Yes. I think maybe they have already get the DC but because for DC we really need to short circuit 2 terminals that and a DC circuit on it.
So I guess just the responsible person does not have like another self to watch like 2 groups with high voltage DC supplies.
Yes. So that's all. Do you have any question?
Yes, actually, it's about fuse break. Like there was something mentioned about inrush current.
Sorry.
There was something mentioned about inrush current, which is related to the fuse break that you're using.
Wait, who cancelled this?
Because I forgot to check in.
Shut.
But that's okay. No, I can't.
I was counting on the tech to stay here to finish those safety analysis. That is okay.
Okay. You can scan it to retain that for 20 more.
How to do it?
I can do it right now. Give me 1 minute.
But it's okay, I could do it him to take a shower first.
That's okay. Just the reservation again. Why it's so slow? nervous. Where's the QR code? Oh, you're rechecking. So what's your question?
Yeah, I had a question about fuse break.
Yes.
Like here it is mentioned that inrush current like cannot exceed 14 amps.
Yes. Oh. Oh yes. But I think this is a fuse. It's not a circuit breaker. I think it will allow us to have a current more than 14 in a quite short time period.
Okay.
I would say the current graph would just be something like it's AC, so or it's just something CBDS. So
yeah.
what we need to measure is this is the IS.
That's the first maximum in the first period.
Yes.
Okay. But yeah, how the device is going to catch that moment, the highest moment?
I think it mentioned that there is a special mode in Fluke that are designed to catch this.
Okay.
So we just need to find the mode.
Mm.
But I think last week during the lab, we witnessed that the room next to us spent quite a lot of time to find out how to find this mode.
I know the mode. I've used it once.
Oh, that's great. That's great.
Did you guys remember that I used to check to see whether our body was right?
Yes.
Because do you remember it's like 83.3%?
Oh,
Oh no, it's not percent. It's 83.3% is the power factor.
So still any question?
Not for me.
No.
Oh yeah, okay. We are free now. So do you see?